In this lecture, I want to talk about writing the equilibrium constant K for situations where we have heterogeneous equilibria. That simply means that we have species of more than one phase. So solids, liquids, gases, aqueous phases, mixed species basically in the reaction. I want to illustrate this by doing some examples. So in the first example, we have 3 solid ions plus 4 gaseous waters in equilibrium with Fe3O4, which is a solid, and 4H2 in the gas phase. This is an example of a heterogeneous equilibrium because we have both solids and gases. Now, it's very simple. Solids cannot have concentrations, so we don't include them in K. Okay, so solids are pure solids. They don't have concentrations, therefore they don't appear in K. So solids don't have concentrations, therefore do not appear in the equilibrium constant. So when we write the expression for the equilibrium constant for this reaction, we just leave out the solids. So products over reactants, the only gaseous product is H2. We would raise it to the 4th power because that's its stoichiometric coefficient. And the only gaseous reactant is water. So we would have water raised to the 4th power again because it's its stoichiometric coefficient. So that would be it for the equilibrium constant for this reaction. We don't include the solids in the expression for K because they don't have concentrations. Let's do another example of a heterogeneous equilibrium. In this example, we have 2 carbon dioxides reacting with H2 to make 1 carbon monoxide and liquid water. Now here we have to pay really close attention to the liquid. Pure liquids don't have concentrations either. Only gases and aqueous species have concentrations. So when we see pure liquids or pure solids, we leave them out of the expression for K. So the equilibrium constant expression for this reaction would be the concentration of carbon monoxide over the concentration of carbon dioxide times the concentration of hydrogen. And that's it. Okay, pure liquid water would not appear in the expression for K. So notice that's different from the example above. In that example, water was in the gas phase. In the gas phase, it can have a concentration. So you have to be really careful about what species you're dealing with when you're writing your expression for equilibrium constant. So the moral of the story is that only species in the gas and aqueous phases appear in the expression for the equilibrium constant K.